So before we start the event, does any of you guys want to talk about what you guys are doing with the Python? Are you beginner using Python in your day job or trying to learn Python for your future job?
Hi, it's Linda. I am a beginner and learning Python, and I made my first app, which is not completely functional because I have a teeny tiny problem with it, but I really like Python. I started with JavaScript very quickly in a Udacity front-end nano degree, and
Oh,
decided to backtrack and learn Python so I could kind of understand what I was doing. I enjoy Python.
sounds good. Yeah, we are all about beginner level Python, every aspect of Python from working with database, web framework, testing, and sometimes some advanced topic which covers more fundamental of Python programming language. Happy to have you here, and let us know if you have any questions or problems. We are always here to help in your journey.
Thank you.
Hi, Sir Charlie. We see you all the time here. Thank you for supporting us and
Yeah,
being here.
hi. Thanks for what you do.
Yeah. Hopefully, I believe that you used to come to our physical event also in December, January, February time.
Yeah, I did.
Yeah,
I did.
yeah, I miss those time too. Okay. We have Amit, Chris is here, Solomon. Let's wait like a couple of more minutes and then we'll start. By the way, we also have Slack channel. If you guys want to join, the links are in our Meetup page. And if you have any questions or want to learn more, looking for mentors, any project that you need help for, anything with the Python you want to talk about to any of your fellow Python learner or industry experts, you can come to our Slack workspace and pose the questions, and we'll try to help out as much as possible. Hi, Will. It looks like we have a good amount of people, so let's get started for today's event. Thank you everyone for joining today. My name is Nissan Gandhi. I am a software engineer by my day job, and I work at a company called Data Robot here in downtown Boston. We are a Python-based AI machine learning company. So that's the background. But yeah, I do Python in my day job, and I like to teach people. So that's how we start this meetup, and more than often we come together and learn different things. Now today's topic, we're gonna talk about unit test or testing in Python. We haven't touched this topic before, and today we're gonna do very beginning level testing framework or introduction in testing in Python. Going forward, I have planned to touch much more broader topic within the testing area in the Python, especially automated testing. So this is like the first level 1 unit testing in Python tutorial today, and let's get started. So basically what we're going to do today. So we're going to talk a little bit about testing and what is testing, unit testing, Python, stuff like that. And then we'll jump to demo, and we'll cover a couple of use case, and later we'll come to conclusion and I'll say you some future path. And at the end, we have references that I use for this to prepare this presentation. Content is not mine, but I have taken liberty to a lot of places to put together this presentation. Now let's talk about testing. So any software engineering practices that you might be familiar with, testing is very integral part of it, because when you're writing a software, you need a trust that the piece of functionality that you have written is stable, it does what it does, and it is robust and it doesn't fail. And the best way to make sure that things are working fine, or the system that you have built is functioning as expected, is testing the system. And uh, and same for the software also. So when you're writing a software, when you're building a software system, you also need to do the testing. And normally there is a manual testing, but manual testing take a lot of time. And every day, as you build the software, as your software grows, as the new functionality being added, it's really hard to catch up with doing all kind of manual testing. So that's why we have something called automated testing. Automated testing is basically you have this piece of code that does its job, and you write another piece of code which technically try to use the functionality that you have built, and try to see that if it is returning the expected behavior that you are asking for. So let's say you're writing a calculator, and you can have someone who can manually test the whole thing by typing 2 and 3 and see if answer is 5 in addition. Or you can have like a series of tests, so next time when you add some more functionalities, you don't have to do it manually. It takes a lot of time. Automated testing help you to first thing test faster. Second thing, because it's faster, and it just like instantly give you an answer whether things are working fine or not. It also helps you to scale your software, because as you keep on adding more functionality, you want to make sure that things that you're adding into your software is not breaking something that already has been working. So when you have all this testing, it makes sure that when you're adding something, it is not breaking something that already in the software tool. And those who are not familiar with the software lifecycle, or something we call CI/CD pipeline in a software. So if you are going to any industry, enterprise software development lifecycle, what happens is normally they have some kind of a code repository where they write the code and like store the code and deploy the code. And every time someone want to add some new functionality into their code base, they run something called CI/CD pipeline. It is called continuous integration pipeline. CI for continuous integration, continuous delivery. CD pipeline. CD is for deploying the code, but CI is for continuous integration. So what happens every time you write some code, and when you say commit and put this code into repository, the CI pipeline run all the test case and make sure that when you are adding some piece of code, it doesn't break anything that is already there. And then finally, if all the tests are successful, then only it will let you add your code into actual code repository. So automated testing are normally ran in the enterprise setup when you're trying to add new code. So every time you say that, hey, I want to add this new code or functionality into our large code base, before that code is merged into the big code base, it goes through something called CI pipeline. In the CI pipeline, basically they run all the automated tests, and this automated tests are basically the piece of code that you written along with the software to make sure that everything works fine. So that is automated testing. Now inside Python 2.1 is when it introduced unit test framework for testing within the Python. What unit test framework basically is, it provides you kind of like a standard to write the test code, to run them properly and see the result, and kind of like a very managically way you can make sure that all your tests are written properly, ran properly, the summary is being generated, what failed and what ran properly, and everything, all that kind of stuff. And so before Python 2.1, there was a independent unit called PyUnit, which was very much inspired by Java's JUnit. Those who know or coming from Java world, they might be knowing about this JUnit. And JUnit is a library that Java provides to write the testing in Java framework. So inspired by all these JUnit functionality, design and stuff, people came up with PyUnit. And PyUnit was independent component. That means before Python 2.1, they had to manually install the PyUnit, but now after 2.1, PyUnit becomes standard in Python. So every time you install Python, the library comes with that, bundle with that. You don't have to install anything extra. And the PyUnit is changed its name from PyUnit to unit test. So that is a bit of introduction of unit test. Uh, And there are so many standards and ideas about how you should write unit test, or what are the standard practices when you're writing unit test, such as it should uh, only test one piece of code, one unit of code. It should be independently being tested, and all that kind of stuff. We'll go into this later, but there are a lot of other practices also out there about how to write the test and what are standard practices to write the test, and that we'll talk about later. Now, in Python, when you're trying to write the unit test, so the standard library that is we call unit test. So unit test comes with the Python, and now so using unit test you can actually write the test. So unit test is the framework using which you can write the code. Like, this is my test code. Now you have to run the test. So how you can run the test? So for running the test also there are multiple ways. So to run the test, to run that test file, you have unit test, PyTest, Nose, and there are a couple of other framework too. Unit test is something come as a bundle, so it's a testing framework as well as test execution library. But when you're like, when as you grow, normally you want advanced features, more testing capabilities, and then normally people switch from unit test to PyTest. PyTest is built upon unit test, and it allows so many other functionality. Like some of the top of the functionalities are, let's say you have in the unit test, let's say you have a file which has, let's say, 300 tests written in that. And unit test, when you say run the test, it's just gonna run 300 tests. Let's say you don't want to run 300 tests, you just want to run let's say 30 tests which correspond to the particular feature that you are changing. So you can't do that, or you are just trying to write and testing, and like just playing with the certain test case. The idea is when you want to run one test out of a single file, you can't do this unit test. With PyTest you can do the filtering and run particular tests that you are working towards. uh, Also you can rerun the test. There are a lot of other plugins are out there. One of the favorite plugin is uh, PyTest is called parameterize, which I use a lot, where when you're writing a test case, you can say that, hey, these are the input parameters and this is the output I want. So I don't have to write for every case. I don't have to write the separate test. I can just pass on the parameters and list of parameters, and it will pick it up. This we will see in future. But the idea is PyTest it has much more capabilities and it can do a lot more, and it kind of like reduce the amount of time that you spend on writing unit tests, because so many boilerplate thing you can merge and write in a small concise way instead of writing separately for all of them. But today we're going to look into unit test. In future we'll look into PyTest. Most likely in my next meetup I'm going to talk about PyTest. So it's very interesting to learn the PyTest. By the way, this is absolute. Like, if you are going to work in industry as a Python engineer, Python developer, you must know about writing test, running test, or introduction, or knowing how to work with the test, or some experience writing the test. Because the problem I see right now is if you go online and search for, learn about writing some app. So most of the time they will tell you all the code functionality, but no one talk about writing test. It's all about, so everything that you're learning online about writing or your app or web app or anything with the Python, it will have its a core functionality, but it will not have testing. So to learn a testing, you have to separately look for that. So testing is very important. A lot of people don't look into testing because many of the times they are seeing the app is running and working and they're happy and they are like, hey, I'm going to apply for a job. I know how to build the app. But if you have never tested how to work with the testing, it's going to come very badly on you. So the idea is, if you are pursuing career in Python, learning about how to write test and knowing about the testing is absolutely important. So this is should be in your pipeline of your career in Python developer, Python engineer, if you're a beginner. So what we're going to do right now, so we're going to start with writing simple unit test, and then we'll use something called setup and teardown. Setup and teardown is basically, if you're writing a unit test and you want to have some kind of setup to prepare your test. This is being used so many times. Let's say you want to test certain functionality of some other system, and you have to set up your authentication, ID, password, client, everything. So inside the setup, you can do all those kind of setup. Then you can write test, and then finally teardown will basically release all the resources. So setup and teardown basically help you to do some kind of boilerplate thing that you have to do before actually testing something. And that is something useful when you are working with the some kind of integration systems where you are testing the component that has to be tested over the network or over the database and stuff like that, or you are testing some functionality that require database access or database need. So in the setup you can set up the database. In the teardown you can release the database, and then you can actually test the functionality in between them. So that is setup and teardown. We'll see a small example of TDD. TDD is called test-driven development. Test-driven development is a very famous or very desired way to write a software where before you start implementing any functionality, you first write the test. I want to add the functionality before I write the code that operate on logic of addition. I write the test which says that, hey, if I call this method, this is how the output is supposed to be, which is basically telling that uh, uh, this method, what the input should be and what the output should be. And then you write all of them, and then because there is no functionality, it will all fail. And you start working on the feature after defining all those tests which will initially fail. And over the time you keep on developing the feature until all the tests pass. And when all the tests pass, you know that, hey, you have covered all the cases and your functionality is complete now. So that is a TDD. We'll see one small example on that too. So let's get into it. We'll start with the demo. So we will I love PyCharm and I use it a lot. So we'll keep using PyCharm. Hope you can see that. So first thing first, let's create small a file called calculator. Now this calculator file, in this file, we're going to write down a couple of functionality or code, and then we're going to test all this code. Let me see if I can zoom. I think it's just. Zoom. Sorry, I should have looked into editor tab. View, active editor. Okay, this will work. Okay, so let's get started. Let's quickly write some functions, and it's a calculator, so we're gonna have add some multiplication division. So quickly how we write the method. We start with def, then add, name of the method, then variable parameters, whatever you call it, a comma b, and that should return a plus b. Another method, subtraction, a comma b, and that should return a minus b. Another method, mul, for multiplication, a comma b, and that should return a into b. And division, div, a comma b, and that should return a divided by b. This is a Python 3. So for those people who doesn't know about the Python 3 and Python 2 difference, so there is a small difference in division method or division operator when you are using Python 3 and Python 2. So we'll look into that later. Anyways, so this is our sample method, and now we want to test. So how do we start? So first thing first, all the testing class that you write. So if you want to test calculator, ideally you should be creating another class, and that should start with test. So test underscore, and then name of the actual class that you are testing, or actual model that you are testing. So in our case, calculator is what we are testing. So we're going to write test calculator. This is a standard practice where all the testing code you write, you start with test underscore. Optionally, you can also create the test directory and put all your testing files there. So test underscore calculator. Okay. Now Now, how to write unit test for Python. So first thing, as I told you that we're going to use something called unit test, and that unit test is already standard. So we don't need to install anything there. So I'm just going to do import unit test. So this is the library that we're going to use. Now, how to write the test case for all the functions. So when you're using unit test, you have to wrap around all your testing code around a class. So you have to write a class, and that class will inherit unit test, and then it will do. Then under that we have to write all the tests. So let's start with that. Class test calculator, and then unit test dot test case. Now this is important. So why we are using a class? So that we can inherit unit test dot test case. And those who doesn't know about the Python object-oriented programming, this is the way to extend class. So here our test calculator is extending this test case class. When you are trying to extend some other class, separate class, you write them into this kind of like square bracket in your class definition. So this tells that we're going to inherit all the functionality that is defined into test case, and we'll see how we do around that. So this is the first thing. We need to do test calculator. Now second thing, all the functionality that you have to test, you have to design the method for each of the functionality or whatever testing you want to do. And all these method in which you're going to write your testing code will start with test underscore. That is also absolute requirement. This is the requirement because if you don't do def test underscore, if your method doesn't start with test underscore, it will not work. Basically, when you're trying to run all your test suite, it will skip everything that doesn't start with test underscore. So if you don't write test underscore, this method will not run by your test runner. So you must start your method name with the test underscore. That is absolute requirement when you're using unit test. So now test underscore, then add and self. Now what you want to test? The function that you want to test, it living in a calculator module. So we need to import that. So import calculator, and now we can do self dot. Now what we want to do? We want to measure the calculator's add functionality. So let's say add 1, 2. This is our function that we want to check, whether we want to check that whether the result equals 3 or not. So how we can do that? So this is the way to call the method, and this is the way that we know that this is the input, and we want to check what the output look like. So calculate.add 1, 2, and we want to check the output is 3 or not to make sure that this add functionality works as expected. Now, how we make sure that the this works fine? So your unit test come with the preset methods that help you. So one of all of them are start with asset. So asset false, asset equal to, asset almost equal to, great, asset equal to, asset greater than, less than. All these functions are there. Asset is none, is not none, is not, less, is instance. So all these are functions that you can use to make sure that to check basically the functionality. And if you see here, so we want to make sure that asset equals, asset equals or equal, both are same. Our calculator dot add 1, 2 equal to 3. So this is our first test that we are trying to do here. Test method, and then now you want to run the test. So how to run the test? So in your terminal, can I zoom in more? Okay. So if you are using PyCharm, like this, you can just run the unit test. But if you want to run this from command line, what you can do is you can type Python -m, and -m is for module, unit test. So this is important when you are trying to run when you're using unit test as your test runner. You say Python -m unit test, and finally you write the test file name. So in our case, test calculator, and then you say run. So if you can see here, ran one test, okay, and this single dot which says that there was a one test which was run successfully. Now there is one more thing. Let's say if you don't want to use this -m, you can also do something like you can run the unit test, or you can use unit test to run the whole thing internally. So for that, if underscore name equal to underscore main. So many people might be knowing that we do this underscore name underscore main. Why we do that? So when we are trying to import something, it doesn't create the circular import and trouble like that. So idea is, when you're trying to run something within the file, you always put them behind this particular code block. So make sure that when you are importing this module somewhere else, while importing, it doesn't execute this method, because this if prevent from executing this particular line when you are importing this particular module test calculate somewhere else. So we have seen this before in another presentation. So uh, so just a wise to always keep it behind this particular code block. Anyways, so now when we are doing this, we don't have to specify dash m. We can say that Python test calculator, and it will still run, and it will give you the result. So this is some kind of like a way to like escape your dash m requirement to write the method. Now we see here self equal to 1.23. Now let's kind of like so this is just one case, and we can create multiple case to see that it works fine. So let's say we want to see that if negative works fine or not. So we say -1, 2, it should return into 1. Let's say -1, -2 should be -3, just to make just rounding up that it works well, -1. So now that we have written this, so when let's just rerun the whole thing again and see if there is some kind of error. Now if you see here, although it's we are doing 4 kind of test, it is just saying that one test ran, because this one is considered as a one test, and anything that failed within this will anything within this will be considered as a one test. So that's why you say test one. So if you want to have second test, let's do the subtraction test. And I'm just going to copy paste a lot of this. Sub. And if you see here, 1 minus 2 will be -1, -1 minus 2 -3, -1 minus plus 2 will be 1, and this will be 3. So second element will be subtracted from first element. So anything that second element is, you have to add like minus and see what the results come out as. So now if we run this, now that we have 2 tests, it says ran 2 tests now. So that's how it considered test 1, test 2 based on the individual methods. And let's say how it looked like if something fails. So let's say we remove this one, and this will like make our one test fail. And let's see how the results come out. So it says that the first one F. So this F specifies that it fails, and then second is dot. So F means fail, and dot means it passed, and it says first pass, and then it tells us the trace. We can see here that assess an error -1 is not equal to 1, because in asset equal the first part were expected to be first part come out as a -1, and second one was 1, and both were not equal. So it tells that that one test failed. So let's restore this to that. So this is testing like add and sub. Now let's test much more complicated stuff. Def test div. Now div is very interesting because div has so many cases where things can fail. So equal calc dot div, and we want to say that just a easy example, 2 divided by 2 should give me 1. And let's say 3 divided by 2 should give me 1.5. Now let's run this and see what answer comes in. So it ran successfully. Now let's see what happens when you are trying to divide by 0 and what answer comes in. So it says that it's a divide by 0 and you cannot run this. So now you know that because now you have written this test case, it says that your code doesn't handle, divide by 0 thing, and it's supposed to return something called value error. So let's go back to div and fix this thing, and we say that if b equal to 0, then raise value error saying that cannot divide by 0. Okay, now go and let's run this. So if you observe here, what we're trying to do is we are raising an error here. So we have to, when we are testing the code, we need to make sure that, or we are testing here the error. Like what we want to test here is when 0 is passed, it has to create the value error. So I'm just starting. I'm just as an experiment. I'm just saying that hey, compare if this error occurs, then value error has to be there. Let's run the code. Let's see what happens. So if you see here, we three of our testing ran, and value divided by errors, we can see the value error that is being raised by our code, but this didn't help us. So how do we check that your method has successfully raised an error? Basically, that is the question, because it is not going to happen like that. We see that successful code going to work like that, but how to test when code your fail? How to test that error can occur? So for that, we have something called assert raises. So it's not equal, it's the assert raises that will help you to basically verify that the assert has been raised. And now its syntax is slightly different. Assert raises start with, so first thing, what error it will raise, value error. Second thing, the method itself. And third thing is, I think the values 0. So let's say whatever 0. Let's run this thing. So now I say that 3 tests run successfully. So if you see here, if you want to verify that your method is raising some error and it's successfully raising error on invalid case, to check that, how to check that, assert raises value error and then calculator.div. So this is the method that we want to test, and this is 2 inputs that we are passing to the method. Now one more thing, you won't see assert raises being used so many times. This is not considered so many valid testing practice, and a lot of people kind of prefer to use something called context manager. Now context manager is a topic that we covered last in our last meetup, so you can go and look at that one if you want to. We're gonna again check the same thing, want to verify the same thing, that your method raise error when there's a condition of error. It successfully raised the error. We want to test that using context manager. And how are we going to do that? So context manager start with with, and then self.assert raises value error, and then inside that value error, we're gonna do our calculator, and we're gonna call this method .div 12,0. So this is like, so here we are kind of like passing the method name and then parameter name. Here we are passing actually what it has supposed to pass, and then we say that with raises. So we are expecting it to raise the value error, and this is the context manager. This is how we write the context manager, which is basically context manager in the very essence. It is basically wrapping the method around some kind of pre and post processing. So when you're writing this method, it kind of pre-process and kind of like wrap the method around some kind of expectation that this method has to be raised. So context manager, very broadly in general, is the idea where whatever you write inside the block of this with, below this with, whatever this method is written, you execute a piece of code before this whole piece of code is written, and after the whole piece of code is like executed. So with whatever, when you define the context manager executes something, then it goes into, after executing that particular piece, it goes into executing the whatever written inside the with, And once this whole with block is done, it will again gonna execute something. And what it's supposed to execute before and after is written inside this whatever is written after with. So this assert raise already has relevant methods enter and exit that allows it to support with, because self.assert raises has this internal methods called this is the class, and this class has the kind of internal methods called uh, raises and enter and exit, and because of that the with works. Just go and look at my previous presentation, or just look online what is the context manager, you will understand that. It's basically used for acquiring and releasing resources while running the code, resource management anyway. So this is another way, and we can do the same thing. We can run the same code, and this is one of the preferred way to do that. So now this was essentially very basic idea around how to write the unit test, how to test the unit tests, and how to run them. Now let's look into a slightly different idea. So we were talking about this something called test, setup and tear down. So let's go and experiment with setup and tear down. So what is setup and tear down? That here all the testing that you are running, they don't require any additional setup. You can just go there, make the call, and run something. So there is no predefined setup that you need when you're writing the test underscore add or test underscore sub. This line doesn't require additional setup before you write all these things. Now let's create a scenario where you have to do all that. So before that, let's just to go there, let's just create a class quickly called car. Why we are writing this class? Because we want to create the scenario where we need to do some setup and tear down. So what we're going to do is we're going to write the class, and when we're going to write the class, so while the testing, we're going to test the class, and in the testing, what we're going to do is we're going to set up some predefined class objects, and then use those class objects to test different things. So for that purpose, let's create this class car. Uh, Object-oriented concept. This is a constructor, and let's write make of the car and year of the car. So just do very simple make and year, and self dot make equal to make, and self dot year equal to year. We're going to write two more methods for the testing purpose. This is something we're going to test. So those who don't know, properties, basically property will help you to, when you define some method as a property, so it becomes a property of the class. So get and set. So let's define title, and this will return dot format self dot year comma self dot make. Okay, so we're going to define two properties here, and we're going to test these two properties. So what we are actually testing here, so we are writing the class. This class is second method, so we're going to test those methods using using our unit test, and then to test these methods, we're going to make use of setup and tear down. Give the example how to use setup tear down. Is old car, and hypothetically let's assume that if self dot year, and let's wrap it on integer, because people might pass on year, is if your car's year is less than, let's say, 2010, then we'll call it then return true. Yes, it is old, it is less than 2010 year old, and otherwise return false. So there is another property for the car which tells that if car is old or not, and our own defined criteria saying that if car is less than 2010, then it is old, otherwise it is not. Now so this is our method. It has simple make and year. We have two methods, title and old is old car, and we're going to test them. So now let's create the test file for this. So how do we start? First thing, the module called car.py. So we're gonna write our file name test_car. So test_car.py, and then we're gonna let me just zoom in. Okay, and then we're gonna import unit test, and then we're gonna import car. Yeah, let's just do car. Now let's just do regular same thing, class test car, and we're gonna inherit test case. And then let's try writing the method by default, and then we'll see how we can use them. So let's say def test title, and we're gonna say car 1 equal to car and sorry, car.car. We can just say from car import car, so you can just use car, and there it has constructor make. Make is, let's say, BMW, and here let's say 2012. Let's say car 2 equal to car let's say Ford F-150. So we have two car, we want to test title, so we're gonna self dot asset equal car1 dot title, and it should be equal to the string. I think it was let's see, year and make, so 2012 BMW, and self dot asset equals car2 dot title 2008 Ford. Okay, so we are testing the, we just do some simple test, so we know that. Let's also write that thing, so it will be easier for writing. If underscore name equal to underscore name, then unit test dot name. So because of that, so with this we can just run the file and it will run the test. Python test car.py. Okay, so it failed because it has to have this dash that we didn't put it here. So now let's run it again. So is that it runs okay? So so this far it is going okay. So now let's say we have to test second thing. Test is old car. Now what we have to do? We have to do the same thing again. We have to create the same two object, and then we're gonna say is car old. So our BMW is not old, so it's gonna be false. And this is going to be true because our Ford is old, 2008, based on our condition. So let's run this and see what happens. So two tests run successfully. But now if you see here, to run this both test, to run this asset statement, we have to create these two objects all the time. So instead of creating those two objects all the time, what we can do is we can have something called, we can use an internal method called setup and teardown. And this setup and teardown, what it will do, that before every test start, it will run that setup thing, and it will create certain things for you. So even though while you're running test title and test is car old, before these two statement run, it will run this setup, create the resources for you, and then so you don't have to create those resources every time in your test, and then you can just leverage that one time resources being created, and then use those one time created resources to in your application, in your testing code. So you don't have to write all these things. So let's see how it works. And this can be very handy when you have to like create database, or database is one of the weird resources. We are not doing something called mocking, but sometimes you want to use some external services and you have to initiate those services or mock those services. And it's really painful to create and start and prepare all the services in the start of a test every time and then actual test. You can just write it one time. You don't have to keep writing all the time. So this is this is something comes within Python. So when you're using unit test case as a framework, so this framework provides this setup method, and this framework actually run everything inside this method when you're trying to run the unit test. So def setup, and simply whatever you write here, it will just execute it first. Now this car1 and car2 will not be accessible if they are not in global space. So we're gonna put them into self dot. So make them global variable outside the setup class. So in our setup class, we are creating these two object with the self. Because of the self, they will be available in the global, or uh, um, not global, but within the whole test car namespace. So it will be easier to access because of this self and selves being passed. This variable will be connected, and it will reach to everything that we are trying to test here. So again, we don't have to write it 2 times because all these resources are created in the setup. Okay, and then again with that, there is another one, def teardown. Does the same thing, but we don't have anything to tear down. We are just setting up the classes and it's gonna stay. But just for the purpose of printing, let's print inside tear down. I don't know if this will execute, but let's just print it and see if it comes along with the side setup. And yes, so now that we have the setup and tear down here, so we don't have to write those resources, creating a resource. We don't have to create them every time. We just create them inside the setup, and then our test case will only run them. We just take it from them and then run them properly. Let's do the same thing. So, okay, so you can see here, test setup, test teardown, test setup, test teardown. So every time you're writing the test, every time executing the test, it was getting into the setup and then coming out. So you can see a test setup, test teardown, and then the one dot telling that your first method runs successfully. Then again, test setup, test teardown, and then this says that the second test also ran successfully. So 2 of them ran successfully. So this is the example of setup and teardown, which will help you to put aside or create resources before you run all the tests. And you can see here, they are not created one time and then being used. Every time every time running the single unit test, it goes into the setup and teardown. So if you have 5 unit tests, your setup and teardown gonna run 5 times. So that is there. Okay, so now this is the core part that I wanted to touch down on. This is the core functionality that I want to introduce in this presentation. We still have some time, and I'm gonna showcase you something called test-driven development. Now, test-driven development is a process where we first write down all the tests, and then based on those test case, we finally develop the actual functionality, and we make sure that that functionality, when it comes out, it works fine. So so I'm going to leverage slightly something more complex here. I'm going to create a Flask web app here. I'm going to call it app. And so what you're trying to achieve here. So what we're trying to achieve is we're going to create a web app. We will create the APIs, web APIs, and we will define the web APIs, but we will implement the functionality based on testing. So we will first we'll just write the write the app, get it up and running, and then we will go and write the test that what API should return, and then come back and implement API actually based on define the test case. And we'll see that initially nothing will pass, and at the end everything will pass. So this is how we're going to do that. So but even before writing the actual functionality, we have to do some setup. And because I'm using Flask, let me create the Flask app quickly. Creating a Flask app, first we need is so we need to install Flask. This is my fresh environment. So, and we also will require one more thing called request, Flask and request. These are 2 libraries that we want to install. So we're gonna put them in requirement.txt. If you are using PyCharm automatically pick up the library is defined into requirement.txt, and if you're not installing your environment, it will tell that, hey, you have written these two library in your requirement.txt, but they are not installed, so please install, and it will just install them in background. So while that happens, let's just write the code. Import from Flask, import Flask, and that will come around once installation is done. And then we're going to create an app equal to Flask underscore name. So here is our app, and then finally we're going to run the app. So if underscore name equal to underscore name, we're going to run the Flask app dot run in debug mode, debug equal to true. So this is the minimum setup that you require to create the Flask app. And now let's just create one simple route to know that things working fine. So app dot route def index home route, and we're just going to return hello world. Sorry, it's parentheses. Okay. So just to see that our app is running, Medium app is running, you just run the app. So this app is running on 5000 port, and let's start with the test, writing the test itself. So we're gonna again create test underscore app. So this is our test file. We're gonna do the same thing, import Unittest, import, we don't need to import the app because we are testing. This is more considered as a functional test because we are not checking the unit, we are actually testing the platform from outside environment. So I would put them into more of a integration test or functional test category than unit test, but test API, and same thing, unit test dot test fees. Okay, so def test underscore home API or index API, whatever you want to call it. Now we're going to test that. Now how to test that? Now we need to use something called request. So request is the library that allows us to make different kind of requests. So we are going to make get request to HTTP localhost and port 500 for 5000 local host 5000 and slash, and what you're going to see is so you're going to get the result equal to this, and then we're going to say that assert self dot assert equal result dot content, and what is the content of this thing? Hello world. Hello world. So what we are trying to do here, so this is more like external testing. I would put them into functional test. We have an app. This app has this port slash, and it returns hello world when you reach this API. Now we are trying to call this API, and we see that whether when you call this this home API, whether it returns the hello world or not. So let's just say run. You can run directly, by the way. Okay, so this is a so if you see SSN error, this is more like a bytes hello world compared to let me do str. This is a Python 3, and it automatically convert data type into bytes. So that will create a problem. Okay. Okay. There is another way. If you don't want to assert the content, I can fix this, but it will take some time. But you can just assert result dot status code equal to 200. So it says if 200 says that everything is okay. So it says okay. So status code basically say that your request was successfully received. So that is what we are comparing here. So it just says that our function working fine. So now what we want to do is we want to create one. We want to have one more API. Let's call this sum because we are doing sum before def sum, and we're we're going to call it not implemented error because we haven't implemented that. Now what we're going to do with this particular method. So now we're going to define that what it's supposed to do. So test sum API, and so what you're going to do. So first thing, for sum, we want to pass two variables to two particular methods that will be two particular variables that will be passed in our request object. And as a response, we want a result that says that what is the sum of those two numbers. Second thing is it has to be post API. So we want to make sure that it is a post API because get is only get. When you're performing some kind of operation, it's a post. So hopefully you know the difference between get, post, put, and delete, and all this kind of API. It's a separate topic. I'm going to not cover that. So let's define what we're going to do here. So what it's supposed to do is so first let's create our data object. The data object is going to be basically a packet that you want to send. Which it will have let's say value 1. It will have two keys, key value pair, basically two value 1, and let's say 3, and value 2 is going to be, let's say, 4. So this is our package, or the data package, or data that you want to data packet that will be sent along with the API, which will have value 1, value 2, that which has to be summed up. And then now what we're going to do is the result equal to we're going to use request dot post. We're going to use post here because that is what we need here. And if you see the post API, if you see it requires data or JSON, like either data or JSON. So it is a requirement. Let's start first with the path, HTTP. So if you see here, I'm typing HTTP all the time. So this is something that could go into setup dot, like the setup method. So I don't have to type this all the time. It will just give me inside setup. I don't have to create the API. I just have to create the fixed variable sum. So let's just slash sum. Okay. Sum, and then we want to drop this package. So data, and so result, and what result we want to expect. So we want the content of result to be expected result equal to we want result and answer 7. This is something that we wanted here. So basically what in self dot assert equals expected result, comma result dot content. So what we're trying to do here, we are saying that, hey, this is the API that how it's supposed to function is when you say when you're doing the post, it's supposed to take these two data as a value and value 2. It's supposed to return the answer as a result, and the value has, this is the value, but it says that it has to have result, and this is the basically input that your API supposed to have this sum. It's supposed to be post. It's supposed to read value 1, value 2 from the data, and it's supposed to return the whole thing with answer. So this is the spec that we have given for the API. And now, of course, if you run this, it's going to fail. Unit test is going to fail, saying that so these are test API and then test some API because not method is not allowed, basically saying the method because method is not there. The idea is this is failing. We need to make sure that this passed. So how we do that? So let's go into app.py and let's start building up on that. So first thing, it says that method is not accepted, and when you say at route, it basically assumes that it has to be, it is only get. So we need to make sure that it also accepts the post method. So to do that, we need to do this. So it tells that, hey, now my sum will accept the post. And now if you run the whole thing, it will say that it is giving some other error. It is not giving me, the method is not accepted. So first thing we fix that the method is not accepted error, which is basically because we were not accepting the post request. Now we accept the post request, then that error has gone. Now second thing is we need to take those two variable, value 1 equal to, now we need to use something called request. So request will have all the functional, everything that comes in the request in your web request. So request dot, and this is a form database because basically you are passing the data into data. So this is a form data, value 1 and value 2 equal to request dot form value 2. So we know that because of the functional test that the values are coming in value 1, value 2, and we are storing them in value 1, value 2. Now this both value going to be in the byte format. So we need to convert them into integer because they travel through internet, and it's a Python 3, and Python 3, everything that is travel through internet or travel through net or travel through web API gonna be in byte form. So we need to convert them into integer. So how we do that? So in the Python 3, to convert this byte into integer, we have integer dot from byte thing. So let's do that. Let's create just result equal to integer dot from byte value 1 plus integer dot from byte value 2. So this is basically we are just creating the result here, and now we need to send it back. So how to send it back? So we need to also create the response package. So uh, response data equal to, and we need to create this JSON. We need to create this dict. It says that it has to have result, and it basically has to have the result actual value. So this is the data. Now you want to return the whole thing. So return, and when you're returning something, you have to do the JSON file. So uh, okay, this is we need to import again JSON file. JSON file basically convert your this data dictionary, a Python dictionary, into JSON doc, which is all string and JSONized version. So because when you're passing data over the internet, it has to be into certain serializable data format. So string is one of the serializable. So it takes the dictionary, convert into JSON string, and then it send it back. So JSON file is, that is what it does. It takes your dictionary and convert into the string. So now that all is done, now let's again run the test and see what happens. Okay, so let's see what error has occurred. Okay, so patch some character error. Okay, so when you're asserting things, we can always look into what exactly went wrong. So first you want to see is assert dot status code is 200, which tells that if everything went fine or not. And this time I'm going to run the whole thing through terminal. So we don't have that thing. So it doesn't say anything. If underscore name underscore name, then Unittest dot name. Okay. So it's a that error 500. That means something went wrong in our app. So we actually have to check and see here. 500 means byte order. Okay. Come on. Okay, so inside our app, when we send the data, it errored out something here. When you're trying to do the sum, value 1, value 2, integer from byte. Okay, let's just try this and see what happens. Value 1. I'm also kind of new to Python 3, so Python 3 has a lot of these data type changes, which is kind of confusing. We still use Python 2.7 in our company, so I'm not so much used to handling with this kind of errors, data type errors, because byte was introduced in Python 3, and everything is now Python. Everything is now like sent over as a byte code. Okay, let's go and where is our terminal here? Okay, So it said 34. It basically took them as a string instead of, so we just need to be converted to integer. I think that is how we convert them into integer from byte. Okay, let's try this and see how it works. So basically, if you see here, result is expected 7, but gave 34. So it basically took value and value to 3 and 4 as a string and just concatenate string. So so the issue is with the conversion. The end-to-end API is working fine. We are getting the result, but result is not as we expected because this conversion is not working fine. So now we can see the result equal to 7, but there is a slash n. So that this is okay. This is in the byte form. Okay, so the result is coming out as a, so you can see a result 7 and result 7, but this is in the byte form, so that has to be converted into the dictionary. So where is our test tab? So the result, the expected result dot content is, this is a JSON file, and we need to convert that into actual dictionary. So we have, I think the command was json.dump, I think. So to convert JSON, okay, let me quickly do the Google search. So I didn't practice the whole thing. I just start writing the whole thing. Convert Python byte string to to dict. This is how we work. This is how we write our code every day. We keep on jumping into some kind of thing, and then we Google search and we see. JSON dot, so JSON dot loads. That is what we need here, and that is not here. So we need to import JSON. And JSON dot loads. Let's now run again. So now it is running fine. So basically what was happening is the result came into the byte form, and we have to convert the byte into again JSON form because expected result is in JSON. Sorry, expected result into our Python dictionary. So the result is coming into string, and we need to convert back it from string to Python dictionary. So that's why we need to JSON.loads. But now, as you can see here, we define everything first in our testing, and then we finally go back and implement the whole thing. So this is the test-driven development. Uh, this is the last piece of presentation or demo part that I wanted to showcase with you guys. Now let's go back to our actual presentation and wrap things up. It's already above my expectation. So basically conclusion is, we need to write the software, we need to write the test code because we are writing software to make the software reliable, and Python has so many libraries to deal with them. We just saw unit test, and that's all. We haven't explored much yet. We haven't explored mocking, we haven't explored parameterized testing, and so many things that you can do if you want to explore. Mock is the first thing that's going to be a level 2 in the testing. Talks is for different, when you want to test in different environment. Let's say you want to run test in Python 2 and then Python 3, and make sure that your testing or your software work in Python 2 and 3. Talks can do something like that. Hypothesis is more like it gives you some kind of a parameterized testing environment to see the result. But mock is something that that is very important as a skill to learn about how to use mock in your testing, because let's say you want to testing some module that require database connection, but when you're writing unit test, it is not supposed to talk to database. So how you can test something that require database connection, but you cannot connect to database? So what you can do is that you can do something like mock, where whenever there is a database call, you mock that method with something else. So you say that, get database result. So you say that get database result equal to XYZ, So your unit test will just use the mock to replace that database call with some kind of written result. You didn't use that. You can use so many other things with the mock. And as I was talking about that, PyTest is very important framework. Unit test is very elementary, but when you are upping your level in industry, everyone use PyTest. So you need to learn about PyTest and how to use PyTest. PyTest is very easy. I can literally run everything that I ran right now using PyTest. I can just say PyTest file name and it will run everything that I did right now. I have to install PyTest. PyTest doesn't come as a standard. You have to install PyTest using pip, and it will just work as it is, but it will give you much more flexibility and much more things that you can do. So thank you very much again. This was the end of the presentation. I hope you learn a lot about Python testing and at least something to get started in your journey. In future, I will be covering more about PyTest, mocking, and much more slightly level 2 kind of testing concept that will help you. Hopefully, writing the unit test, setting up the unit test, using setup and tear down, and a bit of test driven development. This is something we are taking home, and I hope that will be useful in your future journey in a Python. Again, we are building a community. If you have any questions about your learning path, we have Slack channel, or you can even text me on my Meetup messaging also. A lot of people send me messages that I reply them. If you want to present something that you've been working on, you can send me an email so we can set up something for you. We are happy to have more people coming in and talking in our Meetup, and uh, I have tried to bring people in the past, and so far we don't have much lineup in future, but if you want to talk, you can reach out to me. Our friend Amit, probably we haven't start talking yet, but he will be presenting soon. Yeah, just reach out to me. Doesn't has to be complicated. Something very simple you just learn right now, and you can just come and teach or talk and share with the people. Uh, okay, that's all. I'm gonna stop talking now. Thank you guys. Thank you very much. Have a good night, and we'll meet next week. Where is my here?